Okay, so in the previous video, we were able to solve the house robber problem with a top-down approach. In this sort of video, we'll shift gears to the bottom-up approach, which is pretty much the dynamic programming approach that we'll always suggest for most of the dynamic programming problems because of two reasons. It optimizes the runtime complexity as well as optimizing the space slash memory complexity. So once again, I still have an array of numbers. This corresponds to the houses in a line or in the estate that we want to rob over here. And we still maintain the sort of base case that you cannot steal from two adjacent houses. I will not recall the problem. If you've not watched part one, kindly watch part one for the sort of full description. So in the previous video, we were able to see how to do this with a bottom-up approach. You're able to see the recursion layer and you're able to see the repeating sub-problem. Now we'll try recreate the repeating sub-problem. Instead of from the end here, which was the top-down approach, we'll start it from the beginning here, which is the bottom-up approach, where we start from index 0 going forward. So what we'll do here to make it work is we already know how this is supposed to go. So just my apologies on that one. So here's where we are at. So let's go ahead and first of all define like the first sort of index as the first max. So if my array only had one element, it would only have that max one as it is. If my array had two elements, I would have the second maximum, which is going to choose the maximum between 7 and 2. So think about that sort of instance. If we only have one element, we go ahead and choose that element by itself. If we have two elements, we go ahead and choose the maximum of the two elements. So I'll call that sort of entry max 2. Now, what happens if we have a third element? If we have a third element, I need to go ahead and add max 1 plus this 3, right, as my first option versus max 2 as my second option. And you remember what we said? It's either you maximize what you can steal from this sort of array before the previous one plus the current array versus what you can steal maximally from from up to the previous array, which is up to 7 there. And that's what we can summarize as max 1 plus 3. So you can see with the black lines versus what you can get straight up from max 2. So the maximum between those two entries, the summation and max 2, is what will tell us what max 3 is. So we're still maximizing between two sort of instances there. And that's how we get max 3. But now, because this is now going to be a bottom-up approach, we'll go ahead and maintain and make sure that we're using constant memory. So we'll keep up this loop by going ahead and after getting max 3, we go ahead and make max 1 be equal to max 2. So this max 2 becomes the new max 1. And then whatever we get as max 3 will now become our new max 2. And in the same way, we can go ahead and compute the new max 3, which is going to be max 1 plus the next element, right, to get that sort of max 3 versus the max 2 here. So when you think about here, those sort of two comparisons will give you the maximum here. And this is going to be the loop we'll keep playing up until we finish this sort of array or the length of the array and so on and so forth. So this is one of those challenges where if you understand the top-down approach, it's very easy to shift gears to the bottom-up approach. But you'll tend to see the moment you get the gist of the bottom-up approach, it will become easier and easier for you to start thinking about problems from a bottom-up perspective. But at least for this challenge, I wanted to give you both scenarios so that you understand how they could be implemented differently. Okay, so now let's shift gears to the code. So previously you saw we did the top-down approach of dynamic programming with memorization implemented. You remember we did have some problem where we actually had to declare that sort of empty dictionary so that we don't encounter any problems with how we decided to save records onto our dictionary. So let's go ahead and just get started on this one. And here, I'll just go ahead and create a second function. So this function, we're going to call it rob2 instead. So let's call our function rob2, and it's definitely also going to take an array of numbers. So we'll call that array of numbers nouns. I just need some space down here, so let's go ahead and do that. So we should be good. Okay, so now let's think about what we need to first do. So regardless of whether it's bottom up or top down, we still know that the first two first, this sort of two conditions still apply. So if the length of nums, which is the array that's here, is equal to 1, then we'll just return that sort of element in that particular array. If the length of nums is equal to 2, then we'll return the maximum between the two numbers in that particular array. So the one that's on index 0 and the one that's on index 1. And then after that is when we'll start defining how exactly we'll figure out the maximum. And to get started, from the diagram there, we said we need to get a max 1 first of all, and then we need to get a max 2, right? And when we come to this diagram, you can understand that max 1 automatically was the first element in our array. So that will always be nums index 0. So that's what we'll start with. And then we'll go ahead and realize that max 2 is going to be the maximum between these two numbers, right? That 2 and 7. So it's going to be the maximum between the nums element at index 0 and the element at index 1. So we've done our first two initializations. So now we need to go ahead and do max 3 onwards. This is where we need to introduce the for loop, right? Because this is going to be a repetitive process onwards. So we'll go ahead and say for I in range, and you want to go for the range length of nums here. I will go ahead and say that we now understand that because you already have the first two elements, we need to start from range 2 instead. We'll go ahead and do that sort of test case to make sure everything's okay. So from I in range 2 till the length of nums, right? That's where we're starting. We'll go ahead and do the first computation, which is going to be, let's find max 3. And we said max 3 is going to be the maximum between max 2 and max 1 plus the next element. So let's come again here to max 3. So it's going to be max 1 plus the element that's here on that particular front versus max 2. So we already know we're trying to find the maximum between max 2 and the other one is going to be max 1 plus nums, and the position here should be the third index, which is in this sort of front 0, 1, 2. It's going to be 2, and you know we're starting the range from 2. So this is definitely going to start from I, and then we can keep improving it all through. And then right after that, we'll go ahead and make max 2 should be equal to, so we'll do, because we don't want to spoil it early on, we'll make max 1 be equal to what we had as max 2, right? And we'll make max 2 be what we had as max 3, right? And this is the best way to go for it, where you first of all assign max 2 to max 1 before you assign it to a new figure. And that's exactly what we did here, where after computing that, we are converting this to a max 1, and then we are converting this to a max 2, and then we can compute max 3 in the same way as well. And we'll run that particular loop up until we're done with it. And when we're done with it, we'll return the max 2, right? The final max 2 that we're going to have in that particular front. So in this sort of bottom-up approach, we don't need a dictionary because we already know that this sort of switches we have between variables is what's going to matter for us. And we should be able to get an end solution very, very simply. Now, let's go ahead and confirm that we can actually get a smooth solution of it. I'll just go ahead and copy paste this sort of print statements. Once again, this is not the best way to do unit testing for your functions. You can work with unit tests, or you can even work with the SAT functions. We're just doing this for the sake of speed so that we can be able to see what it is. But in the final code I have shared, you'll be able to see the full code with all the unit tests that it needs to pass. It won't just be 2 test cases here. So this one I call it rob2. So for this efficient one, which you're calling rob2, right, I'll just add rob2 there, and we know that this one, the answer should be 12, and the second one, the answer should be 4. Let's just go ahead and watch and we see if we need to improve anything. So we are having a problem here. So it is saying we have a problem on the print. Okay, I see where the problem comes from. We did not eliminate the dictionary, so this is not supposed to be there in this particular function. So for our second function that's bottom up, you just need to put in the nums straight up. So we'll go ahead and run that. Okay, and you can see we get 12 and 4. And there you go. You've seen how we can approach this problem with a top-down approach and a bottom-up approach I will still go ahead and stress that the bottom-up approach was way more efficient to implement. We had no problems dealing with the cache. At the same time, it's the most ideal way to deal with dynamic programming problems because it optimizes for both runtime complexity as well as space complexity because we're using constant space, right? And all of them will use linear time. So that's worth noting. The time complexity here is big O of n in both algorithms, but in the second one, the space complexity is big O of 1, whereas in the first one, the space complexity is big O of n. So the second one is optimal for both instances, and that's what you need to go for, as we discussed in the Fibonacci video, which were the previous sections all through. So go ahead and attempt these challenges by yourself. I would actually go ahead and suggest, after trying to replicate what we have over here, go ahead and try House Robot 2, House Robot 3. Those are all different sort of versions of this similar problem, and see how you can think differently to find a proper solution for both challenges. I know for House Robot 2, the houses are in a circle. So you can't steal till the final sort of index. You have to be slightly creative about that. But that's a challenge for you to think about. But always remember how dynamic programming works and think about that sort of efficiency layer you get by using a bottom-up approach.